Hi, Daryl Wittenberg here again today with Industrial Solutions and Innovation. Today we wanted to take the opportunity on a system that we are actually testing out and getting ready to ship to a client in Colorado. This is one of our ready-to-weld -3 systems that's actually a combo system. It has both MIG and TIG capability on it. We get questions on occasion from people that we're doing demonstrations for about real-world applications. How does this handle welding a pipe to a fitting? So what we've got tacked up here, and Colby, if you would, go ahead and show the arc view side of this. We've got tacked up a 6-inch Schedule 40 pipe with a weld neck flange. We have made this as real world as we can, and whenever we rotate this part around, you'll be able to see that we've actually ground down those tacks the way we would for production or the way that we would in training. What we're going to show you here is a root to cap Schedule 40 weld to a 6-inch weld neck flange, and we're going to do a root pass. You'll see a stop. Normally we would tell you we're going to clean, but for the sake of the video, we're not going to clean that weld or that root pass. We'll rotate it around so you can see the root, and then what we'll do is we'll fill in cap without stopping or breaking the arc. After this weld, we're actually going to pivot this column and boom around, and on the parallel system, we're going to do a socket weld for a slip-on flange so that you can see that we can do this. We have a articulating torch here that allows us to tilt the entire cross slide in the plane that we're welding. So when we have to adjust the arc length, it's actually in the right plane. So we'll get started with this right now. We've got Samantha running the controls. We'll be showing you her perspective as well. She's actually going to run this weld remotely. So I'm going to get out of the way and we're ready to weld. Now we are actually running on this a 75-25 on the root pass. We have the availability of dual solenoids on this system. So for our root pass, we're going to go in with 75-25. On the fill-in cap, we're going to be using 90-10. That's programmed in on this weld program so that she doesn't have to worry about changing the gas solenoid. It will do that automatically for her. You can see there the joystick she has to her right. That is to allow her to steer and to keep the joint in the center, or keep the arc in the center of that joint. She can also adjust oscillation speed, dwell times, things of that sort if this fit up is not perfect, if it gets thinner or wider on that root opening. From this camera angle, you can really see that we're getting penetration there. We're consuming the edge of that bevel, and it's going in very smoothly. We're running about 3 inches a minute on the rotation speed. Again, for demonstration purposes, we normally don't get really aggressive with the numbers, but this is pretty real world what you would expect to see. We're running an 045 wire. This is carbon steel. It's a 70S 6 wire. And our gap on this is 1/8. It is a ground-on bevel. Now the fitting obviously was machined, but we have flapper wheeled that. The pipe was a burned bevel from our Watts profiler. We have a Watts 244 in our system and our rental fleet, so we cut the bevels on the pipe using the Watts, and then we flapper wheel those to remove the shellac from the pipe, and we fit it up. So this is about as real world as we can make this. So we're coming into attack here. You can see that that's been feathered out or tapered, and she's got that pretty thin, so we should see this reconsume that tack as we go across it. We're using a Xyrus camera system, and the Xyrus system gives us a lot of feedback. So we can actually see the temperature on that camera. It is water cooled, and so we can make sure that we're not getting too hot on the camera. And as you can see there, she can steer while she's doing this. We got a little high-low that is magnified on the camera. So any high-low is going to look substantially worse than what it is in real life. But this does give you an idea. You can see there that we're accommodating that high-low as she steers across that. So this root waveform that we're using here, this is actually something from EWM. It's called root arc. We're using a Phoenix 552 power supply. It's water cooled. It gives us up to 550 amps of power. Normally we don't see people coming anywhere near the max output on this, but for this purpose we're using a 552. And that system gives us the ability to go from this root waveform, called root arc, that's very forgiving and is designed around doing root welds like this with an opening there. We can go, whenever we go to our fill and cap, we're going to use a pulse spray mode. EWM calls that force arc, and we're going to put pulse on that as well. So you'll definitely see a difference when we go to our fill and cap mode. So again, Samantha's steering through that high-low. You can see through that camera angle, we're obviously getting that root in there nice and consistently. And we're coming up on another tack. Samantha is just one of the many folks that we have here at ISI that can help you with support on this product. She is actually a fairly new addition to our team. She came to us from LeTourneau University. She graduated in May, and we put her right in the middle of everything, right out of the chute. She's done a really great job of learning this system. But one of the promises we make here at ISI is that whenever you buy a system from us and trust us with helping you accomplish your goals, we're going to have the support staff here to keep that system running. And so we have numerous people on staff that can help you with technical challenges. We can help you develop welding procedures, really get you through that learning curve. One of the key things we want to show you here is that when you watch what Samantha's doing, she's not overly active. She's letting the system run. We want the system to do its job. So we want consistency in our fit up. It doesn't have to be perfect, but we do need to have consistency there. And she's steering when she needs to. She's adjusting some speed on occasion, but by and large, if you just notice what her hands are doing, she's not getting overly aggressive with the controls. She's letting the system operate. So we're coming into our tie-in on that root pass. Now again, we're going to shut the arc off after this. We actually have that programmed into our system to automatically kill the arc after the root, because we would recommend that you come in and wire wheel this and clean it. What we will do is, as soon as the system frees her up to do so, she's going to elevate it just a little and then we're going to rotate that around so that you can see the consistency of that root. And again, that camera really magnifies that high-low, but you can see where our ODs were not matching perfectly, the ID wasn't matching perfectly, and she steered right through that. The system does sense the arc gap and automatically adjusts to keep that arc length the way it needs to be for that ovality, for that high-low. All right, so there's our root pass. She's going to jog it around to a starting position. And she's going to put it into the next mode, which is going to be pass 2 and 3. And she's just checking her oscillation there. So our travel speed jumps up quite a bit here. We're at 6.5 inches right here. Again, if we want to get real aggressive, we could possibly go faster. But as you can see, we're above flush there on this pass. We can also run a stringer if you would prefer that, as opposed to running an oscillated fill-in cap. So on this system, we're actually running twin headstocks. While you're welding on one of these headstocks, you can be loading and unloading the parallel headstock. And you have a foot pedal on both, so that if you need to jog things around, grind down those tacks so that they'll be reconsumed, again, loading and unloading, things of that sort, all that can be done while you're welding in the other headstock. So your arc efficiency on this is much higher, and it affords you the ability to take someone who may not have the experience of your golden arm welders, get them in a position to be successful and very profitable and efficient for your shop. Again, just to kind of drive that point home, Samantha graduated from LeTourneau with a welding engineering degree about a month and a half ago, and she's running this system successfully. She's actually helped to develop a couple of welding procedures using the systems. She's very confident when it comes to running it in the TIG mode as well. So the learning curve on this, although it does exist, is definitely not insurmountable. And we always say that the most important part of any system is an operator who wants it to work. And Samantha's really a great example of that. She was real excited about the technology and has done a really good job of learning it. So since this one was able to be filled and capped in that second pass, we can kill this one after we tie in. The system ties in, and then when it allows her, she's going to jog that up just so we can rotate that around and let you look at that. You can see that silicate popping off of that cap pass there as we go around. Again, that is exactly why we would recommend cleaning with a wire wheel after that root pass, just so we're not trapping any of that silicon. Okay, so we have rotated our column and boom around. So now we're on the adjacent headstock, like I said earlier, and we have oriented this slide so that we can now be in the plane that we want to be in. All we have to do to orient this is we have pins that we pull. It rotates around to the angle that we need, and then we drop that pin back in place. It takes about 2 or 3 minutes to set all this up. So we still have our camera system on here, and all I'm going to do now is align things. You can see here I can go up and down. I can go in and out. But Reagan's actually going to run this weld remotely. So I'm going to put the remote pendant down and give him the controls so that he can run this weld from that same screen that we showed on the previous weld with the 6-inch Schedule 40 weld neck flange. So Reagan, go ahead. As you can see here, we are doing just a stringer bead for that first pass. And what we've got in this is we have a system that actually monitors that arc length. So it's sensing that arc length through the arc, and that way if there's ovality, if we're getting too close on one area when that part comes around, it automatically adjusts the arc length up, and we don't have to worry about steering through that. It senses that for us. Currently we're rotating at about 8 inches a minute. We're doing 240 inches a minute of wire, and our current is at 170 amps. And that's where we're getting that arc length control. We actually set a current value there, and that keeps us the same distance from our part. Again, if you're watching Reagan's hands there as he's running this weld, he's not doing a whole lot of steering, he's not doing a whole lot of activity there. He's letting the system run. He's letting the system do its job. And one of the hardest things to do is to give a welder a button to push and a joystick to move, and then tell them to leave it alone and let the machine run. But Reagan does a great job of that. Reagan's been with us almost 10 years. And I was bragging on Laterno on a previous video. I'm going to brag on TSTC. He is a graduate of TSTC in Waco. We've hired several of our technicians from there. They do a great job of getting guys and ladies ready for this industry. And it's really fun to watch them take ownership of this equipment and make it run the way it ought to. So we're going to automatically step into our stacked stringer beads. So once he finishes up this pass, you'll see that the arc, we will not break the arc, it'll jog over. And we'll be stacking those beads. Reagan, how many passes is this going to be? 3. It'll be a 3-pass weld.
I'm running continuous.
Okay. So as you can see, the arc stepped over a little bit. So now he's putting that bead there more to the pipe side. And when that one comes back around, he'll stack another bead there to the flange side. We also have clients who ask us on occasion, can we run flux core metal core, things of that sort. This system can run all of those processes. We've got clients that are using their system to put in TIG roots and a TIG hot using hot wire TIG, and then they will come back and fill and cap using flux core. Any of those processes are fine. We have an increasing number of our clients that are going hardwire all the way out, and so this system is really built to accommodate whatever your procedures require, what your customer may require. So what Reagan's going to do as we tie in on this next pass, he's going to jog it over to the flange side, but then he's going to go over and grab the remote that is on the system so that you can see how an operator would run this if they wanted to run it directly over the torch. We have some customers that when they buy their system, they're not as comfortable running it remotely like he is here, and they prefer to start operating the system using the remote pendant and being right on top of the torch. That obviously is an option that's available to you, but what we find most of the time is within a couple of weeks, running it from the camera is pretty convenient, and you're also not getting near as much exposure to an arc. So each pass on this, we're running at about 8 inches a minute. You figure an 8-inch pipe, we're gonna have about 25, 26 inches of OD circumference. So that's gonna put us at about 3.5, 4 minutes per pass. On a 3-pass weld, we should be done with this somewhere in the neighborhood of 12 to 15 minutes. So you see the torch jogging over. Gonna get that nice tie into that flange. Nice and consistent arc. That force arc mode really cuts down on the spatter. There you're going to see Reagan walking around there. He's going to grab that remote pendant. So if he wanted to run this weld there, obviously that's an option. And he can drive this from there, just like he was driving it from the control panel here, where I'm standing. See that he was making some micro adjustments there, steering. If you wanted to run this same weld using hot wire TIG, it's literally just a 2 or 3 minute changeover. We pop one torch out, drop another torch in its position, and this system is built to readily accommodate you running TIG on one pipe spool and MIG on the next, or vice versa. So it is extremely easy to adapt over to your weld qualification or requirements, and it's an extremely intuitive system. It allows the operator to get very comfortable very quick. Here we are with our tie-in. Reagan, if you would jog it up, let's rotate that around a little bit. You see the silicate sitting on top of that weld, but a very consistent bead profile. So what we've shown you is the ability to do a slip-on flange or a socket weld using a MIG torch. We could also, like I said, we could run this with flux core, we could run this in a TIG mode, whatever your welding requirements are for a particular job. We've also shown you as real world an example as we can, welding a 6-inch Schedule 40 flange to a piece of pipe. Our goal in this is to show you the flexibility, the adaptability of this system. This system gives you the functionality of being able to run all the way up to a 36-inch pipe with a 36-inch long radius elbow on the end. So we can rotate that long radius elbow on this system, which would also mean you can run a 48-inch pipe on this system as well. We just wouldn't be able to handle the sweep of that long radius elbow on the same system. We can adjust the center line of the headstock up and down. We have these hardened rails that drive up and down with a motor, a mechanized drive. That gives you that flexibility of getting to the right center line. Our column and boom is motorized coming in and out, so when you need to adjust for center line and things of that sort, that's very easy to do. And again, to adjust this angle here, it's very easy. I'm going to drive that up a little bit. Make sure I'm clearing that pipe. And then I literally just have to pull these pins. Need to jog that up some more. And there I go. I can swing that back around and put these pins back in place, and there I'm vertical. So that's all I have to do to go from running a vertical weld, vertical position with my torch, my cross slides, to running a socket weld. It's that simple. Obviously it tilts either direction. If I were running on the other headstock, I would need to rotate it the other direction. Thank you for taking the time to watch this video today. Again, our goal is to show you that a ready-to-weld system from Industrial Solutions can mold itself around your application. We want to show you that we are a company that brings solutions to your challenges, because Solutions is our middle name.